Okay, so let's talk about absolute value functions. If I give you y equals the absolute value of x plus 7, then if I want the zeros, if I set x equal to 0, I have y is equal to 0 plus 7, which means y is equal to the absolute value of 7, which means y is 7. So that means we have a 0 at 0, 7. And this is the y int. And then if I say y equals 0, I have 0 is equal to the absolute value of x plus 7, which means x plus 7 equals 0, or x plus 7 equals negative 0. Well, that doesn't happen. There's only one. So then this means x is equal to negative 7. So if this was actually a number, you'd have a plus and a minus. But since it's 0, then you don't have that. And so this is taken care of. So we have negative 7, 0, ordered pair. And so our graph looks something like the following. Here's negative 7, 0. Here's 7, 0, 7. And we have this V shape. Okay. That is your absolute value function. You will get used to that and memorize it in time. If I asked you the domain, well, I can put all real numbers here because there is no division going. So if you look at the equation, there is no division going on by 0. There is no square root sign. So then the range here, well, the lowest value is right here. It's at 0. And it goes up to positive infinity. Okay, and so that would be the domain and range of this. Let's look at random graphs. So if I was to graph something that looked like this, if I go let's say that's at 2. This is at negative 4. This is at positive 4. And this is at 6. And this is at negative 6. If I asked you the domain, you'd tell me the x values over the intervals. So the first thing you notice, this, by the way, is a hole. We call this a hole. There's no x value or y value there. And so what's going to happen is the x values start at negative 6. There is a value there. It's this point here. Negative 6, 4. Negative 4. And so the domain goes from negative 6. It comes all the way this way. It stops at 2. And now it's going to... 2 is not included because that's a hole. It's going to skip 2. And it's going to go on to 6. And there's another point here. So there's a point at 4. 6. Oops, I have that written backwards. 6, 4. Okay. So that's the domain. And then the range here, the lowest value is at negative 4. It comes all the way up. Let's say this is 3. To 3. It doesn't have a point there because there's a hole. Skips over 3 and it goes up to positive 4. Okay. And so you just have to watch if there's holes and there's circles on there. That means it's an empty point. There's no actual point there. You just kind of leave that out. Now the last thing we're going to talk about in this video, we're going to evaluate. If I give you, I don't know why I'm doing 3, but because of this 3. If I wanted to evaluate f of 6 of 4x plus 5, then I want to plug 6 wherever I see x here. So I have f of 6 is equal to 4 times 6 plus 5, 24 plus 5, 29. So f of 6 is 29. If I want to do x plus 1, then I want to do f of x plus 1. Then I have 4. Same equation. Then now I'm going to plug x plus 1 into that x. So I have f of x plus 1 is equal to 4. Wherever I see x, I'm going to plug x plus 1. Okay. And then I'm going to distribute. This is 4x plus 4 plus 5, which is 4x plus 9. Okay, and then finally, f of negative x. I'm going to plug negative x wherever I see x, so this is f of negative x is equal to 4, which is negative 4x plus 5. Okay, so that would be your f of negative x equals. This is important to be able to do, guys, so make sure you practice this. The next one, f of 4 into the equation x squared plus 2x plus 3. So this is 4 squared plus 2, that's not going to be 2 times 4. So this is 16 plus 8 plus 3, which is 27. Okay. And then let's do this last one. Well, we can do both of them. We have f of x plus 1 is equal to x squared plus 2x plus 3. I'm plugging x plus 1 in. So this is x plus 1 squared. Notice I'm using parentheses each time. 2 times x plus 1. Okay. Use parentheses so you make sure you know what to do. This is going to square out to x squared plus 2x plus 1. All I've done is I squared this one, I squared that one. That's the first and last. And then I did this times this plus that times that again. And that's 2x. Okay. That's how I did it in my head. This is going to be 2x. This is going to be plus 2. And so this is x squared. Okay. 2x and 2x, so plus 4x. And 5, 6, so plus 6. So this is f of x plus 1 is equal to that. Okay, and then finally, let's do f of negative x is equal to x squared plus 2x plus 3. And we plug in negative x, so we have negative x squared plus 2 times negative x plus 3. This is going to give us x squared plus, sorry, not plus. This is plus positive 2 times negative x is negative 2x plus 3. So f of negative x is equal to that. And that is how you compose functions and such. So you're just going to plug in the value into x wherever you see whatever value they give you in replacement of x. You're going to replace with x in the actual function, and then you're just going to do the distribution or multiplication that is required to make it what it needs to be. Make sure you guys practice. This is a lot of work, but just practice it. There's plenty on Alex. Thank you, guys.